Okay, so I'm going to go through this now, this first one. I think we need to help this. If you're watching at home, this is the sentence we need to fill in. Between experiments blank and blank, the conquer blank increased by a factor of blank. This increased the initial rate by a factor of blank, therefore blank is blank order. So all I'm going to do is fill this in. Fill in the blanks, basically. So for x, between experiments 1 and 2, the concentration of x has increased by a factor of 3, and the initial rate has increased by a factor of 3. Therefore, x is first order. So we can say rate equals k x to the 1. It gets a little bit trickier for y, because with y, we can't isolate an experiment where only y has changed. So what we need to do is a halfway house. So I'm going to use a little analogy here. Here's Jack and here's Jill, and they have a football, and between them they kick the football 100 metres. And my question is, how far did Jack kick the football? Like, we don't know, do we? Well, that's the same problem here. X has changed and Y has changed. And between them, they've made this change to the initial rate, but without closer inspection, we don't know which has caused which. If, however, I said Jill had kicked the football 60 metres, and between them they've kicked it 100, we could then say, well, Jack must have kicked it 40 metres. We're going to use, it's exactly the same as this analogy, no difference on our question here. We're going to use Jack and Jill, so I call this the halfway house. So, let's have a look. Between experiments 1 and 3, both x and y have changed. So what I'm going to do is, first of all, I'm going to figure out what effect the chemical we already know the order of would have had on the rate. So we know x is first order, we just figured that out. And so if x is increasing by a factor of 2, the concentration of x, and x is first order, x would increase the initial rate by a factor of 2. So the effect of x will be to increase 1.55 by a factor of 2, which takes it to 3.10. That's like figuring out how far Jill kicked the football. Now we've done that, we can figure out what remaining effect has been caused by y, how far Jack kicked the football. And we can see between here we come back to the sentence, and this is all you need to write down. Between experiments 1 and 4, the concentration of y has increased by a factor of 4. This had no effect on the initial rate. Yeah? So in the exam, they'll give you this table, literally write this on the table, like scribble all over it, that's fine. Figure out the effect of the chemical you already know the order of, and that will tell you what effect is left over to be caused by the chemical you don't know the order of. And therefore, say that sentence, it's the same sentence, and you'll get your answer. Have a crack at question 2. And you can just do it on some lined paper if you want, and then we'll go through that in a bit. But again, other than scribbling on the graph, which is your working, all you're doing is saying this sentence for each chemical. And so this would be my overall rate equation for question 1. Have a go at question 2 though. I don't know what to do if you can't see the table, Laura. I'll try and move the camera a little bit closer. Yeah, you got it now, okay. Where's the back there? There we go. Okay. If you're watching this live from home, if you can just type in "done when you're done" into the chat, then I'll know when I can move on. All you should have as your final answer is that between experiments blank and blank sentence 3 times and then a rate equation. Once you've got your final rate equation, if you're watching live from home, can you just pop it in the whiteboard room? Just so I can check everyone's got the right final equation. Don't worry about putting all your sentences in there though, you won't fit it. Yeah, nice one, Will. That's great. So far, so good, Ava. Just have a look at the numbers again, Faye. Between experiments 1 and 2, A does not increase by a factor of 3. Between experiments 1 and 2, A increases by a factor of 0.5, or half. We don't put the x's in for times, Sam. See how I've not put kx, x, I've just put kx. It's assumed that that's multiplied by. You don't need to put the multiply sign. I'd have another think about your answers there, Sam. That rate equation isn't correct. I'll try that again. Got C correct, but I'd just have a think about A and B again. So look, let me do A, yeah? Between experiments 1 and 2, the concentration of A has increased by a factor of 0.5, and the initial rate has increased by a factor of 0.5. Therefore, A is first order. That's proportional. So for this second question, we can start by saying K A to the 1. If you said the concentration of A halved and the initial rate halved, fine, but we really should be talking about in terms of increased by a factor of. And that's increased by a factor of 0.5, that's increased by a factor of 0.5, that's proportional, so A is first order. It's not 0.15 Faye, it's 1.5. (1.2) divided by 0.8 is 1.5. Either between experiments 1 and 3, the conc of y. Oh, sorry, you still get x and y up there. I'm with you. Yeah, nice. I'd think about B again, Sam. And everybody else, if you can't post in the whiteboard room, can you post it in the chat? I'd like to see everybody with their answer, please. The rate equation. No, Sam. I've never go at B again. Do what we did above here. You need to do this halfway house, Sam. Method. Figure out the effect of the one that you know the order of. Look at what effect is left over to be caused by the chemical you don't know the order of. Yeah, nice one, Faye. That's great. Will, you can shoot, Will, if you've got it. Have a nice day. You've got it, Will. All I'm going to do is go through the answer here. Very close, Daisy. Very, very, very close. Just have a think about C. Yeah, nice one, Ina. That's great. Feel free to shoot, Ina. You've got it. That's a nice one. All right, I'm going to go through this just because of time. We need to stop now. So we've already said A is first order. Let's look at B, and I'll just pop your pens down and have a listen now. So for B, between experiments 1 and 3, the concentration of B has increased by a factor of 1.5. I know this because 1.2 divided by 0.8 is 1.5. So if you want to know what factor something has increased by, do the final number over the initial number, and that'll tell you the factor. And if we look at our initial rate, that has increased by a factor of 1.5 squared. 18 divided by 8 is what you get for 1.5 squared. Therefore, B must be second order. So B squared. Now for C, C is a difficult one because again, we can't isolate two experiments where only C has changed. But if we look at experiments 1 and 4, C and A have changed. So first of all, I'm going to look at what effect A would have had. And if I figure that out, that'll tell me what effect is left over to be caused by C. Now we know A is first order, And between experiments 1 and 4, the concentration of A is increasing by a factor of 3. 0.9 divided by 0.3 is 3. And so as A is first order, that will increase the initial rate by a factor of 3. Well, 8 times 3 is 8, 16, 24. So the effect of A on its own would have made the initial rate go from 8 to 24. But the initial rate didn't go from 8 to 24, it went from 8 to 48. So C must have made the rate go from 24 to 48. And so here's our sentence you'd write down. Between experiments 1 and 4, the concentration of C increased by a factor of 2. This increased the initial rate by a factor of 2. Therefore, C is first order. So our equation, our rate equation, would be rate equals K, A, B squared, C, is what we've got. Thank you very much.